Cool. Thank you all for coming. I am insanely humbled by everybody showing up. It's kind of standing room only here. Thank you all so much for showing up. This is Blue Team 101, Building Defensible Systems, a series of short poems by me, Daniel Griggs. So I am actually insanely proud of this slide. Here we go. Are you ready for it? I worked for a few government agencies that I can't talk about here. I co-wrote the STIG, which is the government security guidance for iOS 7, macOS 10.9, and 10.10. And I'm just now getting spun up on the 10.12 CIS guide. I'm going to help, write that. So what my company does is basically we packaged up an entire enterprise IT stack, and we sell that as a service. We focus on government agencies and companies in highly regulated areas, PCI, HIPAA, government agencies like that. I say all this not to brag and try to sell my services, but all these answers I'm about to go over in this presentation are going to sound really simple. You're going to want to second guess and it's like, that's not right. We can do it this way. More hours than I even care to add up have gone into these answers, and it's thousands and thousands of answers. Thousands of hours have gone into these decisions. And one of the key principles of all of that is that security management should never destroy the user's experience. And I chose my words carefully with this. I never said not affect, never destroy. So the typical way in highly regulated environments, we use GPOs, we use configuration profiles, we lock everything down, we turn everything off. What we have here is most of our deployments are relatively small with the exception of maybe Google and Facebook. You guys are kind of rocking it. So we have the opportunity to do things right from jump. So we're agile, we can implement new paradigms, and we can do things right from the start. So we're going to touch basically today on what's wrong with security in the not just in the government, in industry as a whole. I'm going to convince you that real-time monitoring, real-time forensics is kind of the next way to do things. We're going to start you on the road implementing it, and we're going to walk through a couple examples. Security decisions, and try and figure out how we came to that answer for a few different simple examples. So the government loves their acronyms. CDM is Continuous Diagnostics and Mitigation. So basically the government implemented this GPO, this lock everything down system, and now they're spending about $6 billion to undo it and move to this more dynamic way of doing security where you're always taking inventory, you're always watching, you're always managing, and you're always correcting what's wrong. So it's really designed to know when and what changed, and automatically fix what you can, and when you can't fix it, lock down the device. Disable it in some way, whether that's the passcode lock with MDM, whether that is just cutting off network. However you want to disable it, you can put in those kind of controls. But this is not without its problems, because overall security is complex. There's a lot of moving parts. The parts themselves are not particularly complex, but there are many, many, many parts. And users are not at all focused on security. They're focused on getting their job done. So what we need to do is train users to recognize security events and incidents in just plain English and protect. I'm reading from the wrong slide, excuse me. Threats and vulnerabilities change daily, and compromise is nearly inevitable. So the goals of security is to really know when something bad happens, rather than locking down and turning off everything. We need to turn off and lock down what we can, but what's far more important than that is knowing when something bad happens. So we need to facilitate easy workflows for users that are secure. We want to make doing the right thing easy and doing the wrong thing frustrating. And basic security training for users is absolutely mandatory. Think of what Chrome does when you visit a site with a bad certificate, where it makes you click through and then click a very small button that says, do it anyway. It's that kind of user training that we need to implement throughout our deployments. And lastly, protect the data on the device. That's not only the company data, also the user's data. So all data on the device is equally important. So basically, if an attack were to happen, here's kind of how it would move through. So there's the initial compromise. There's some kind of vulnerability that we exploit, get on the device. We establish a foothold on the device, so now I can stay there until you reboot. We escalate the privileges, try to get to be admin. We try to look around. We try to move to a different device, because oftentimes the device that you compromise is not the device that you want. Usually it is some just regular old laptop when really you're looking for a server. You're looking for someone with admin privilege. You're looking for a system administrator, something where you can really get all the data you want, because they have a limited number of actions before they're found. And what our whole goal is to maximize that number of moves they have to make, so we have the maximum chance of finding them and detecting them and ultimately stopping them. But to attack, you need a way in. So a quick run through of some definitions. So the vulnerability is basically a mistake in software used by an attacker to gain access to the system. So the CVEs are effectively a serial number for these vulnerabilities, because we got tired of thinking up creative names: Heartbleed, Shell Shock, Boiled Rosewater, Grumpy Hunchback. It gets hard to keep thinking up names for all of these vulnerabilities. And there's a big list of all these that NIST puts out. The National Vulnerability Database is linked down here. And that's a list of all known and validated vulnerabilities. It's not just, hey, I found this thing with Adobe, you should put it up there. No, they actually check and make sure that it's real before they put it up there, which is extremely handy. An exploit basically takes advantage of these vulnerabilities. And it's kind of how an attacker would get in. So now that there's a weakness, this is what I would do to take advantage of that weakness. And then in traditional sense, the malware or the virus is what I want to do once I'm there. I want to get some kind of process on there that lets me persist through reboot. I want to exfil data. I want to move to another more important system. Or I just want to make your life hard. I want to deny your services. I want to make your network cut out every 30 minutes. Whatever I want to do. So to give you kind of a sense of the problem, I went and I grabbed this morning all the CVEs for Mac off of the National Vulnerability Database. Right now it's a little bit inflated because there's a whole bunch of Adobe ones that just came out. But in the past 3 months, there have been 283 different vulnerabilities, different ways into the system. Some of them are a little bit duplicative, but for the most part, there's 283 different ways I could use to run some kind of program to get into your system. In comparison, Windows for the same time period was 261 and Linux was 183. The real number without the Adobe stuff for Mac is somewhere around 200, but it's still 200 different ways. All you need is one. So luckily, I have this one trick that hackers hate. You know, click here for no more. Could save you thousands. And if only it was that easy, hit enter for more. So how do we actually secure a system and not this fairy tale world? So basically, without an MDM, there is no way you're secure. We're long past the secure and forget. Secure it once, image it, send it out, and never check on it again. That day is so far gone, it is not even funny. And everybody thinks that there's some done state for security, that we work really hard, it'll be terrible for 3 months, we'll code all of this, and then we're done. Phew, security's done, check it off the list. It's not like that. It's much more like Jerry Seinfeld's don't break the chain productivity method. Be better than yesterday. You'll never be done. So you just got to keep working on it little by little every day is what you have to do. And when you're doing that, you need to focus on the endpoint, particularly because we're Mac administrators, and that's what we do. But also, if you focus on the endpoint, you're protected wherever you are. You could be at Starbucks, you could be in the office, it doesn't matter. If you focus all of your energy on the endpoint, you'll be protected. And lastly, don't try to reinvent the wheel. Everybody's facing these same problems. You're not the only organization with these problems, and most of these problems have already been solved by groups of experts. And it's well documented in many different ways, such as these security guidelines. So these not only list what you need to change about a system. In a perfect world, if we took out the user component and locked everything down, they explain why. So we need to turn off SSH because of X, Y, and Z. It doesn't just say turn off SSH. The particular note are the NIST special publications. They're a little bit more general, not just Mac focused. There's some on continuous monitoring, configuration management that's focused on security, and protecting sensitive but unclassified information. All those are very long, but excellent, excellent reads. They're all available on NIST's website. They're free, publicly available documents. USGCB is US General Computing Baseline. That's a government document, again, a lot like the STIG, a lot like the CIS. It's the same kind of deal where do these 200 things to your computer and you will then be blessed and secure. The STIGs I put bottom of the list because they're a little bit hardcore and there's a little bit of politics in making those because that's what the Department of Defense uses. And they want those to be the most stringent, the most hardcore, the most locked down controls. So what not to do is exactly that. You don't want to turn off everything. And I know you can be impressed by my Photoshop skills here. Beautiful. I'm an artist. So it's easier to start with what not to do when we talk about this because you don't want to turn off everything because users will find some way around it. If you turn off file sharing, they'll put everything on a USB drive and they'll drop it in the parking lot. They'll do something worse. And if you treat these computers like a server and turn everything off except for the one thing they're supposed to do, you might as well buy like a Chromebook or an iPad. It's a waste of $1,300 to have a computer like this only do one thing. And when you put it in that kind of frame to management, it makes a lot more sense to them of why are we buying these very expensive devices and making it so they can only do one thing? And I don't know about all of you, but I want my devices to do many things. And this next one's a little bit local to me because I'm from DC, but I see this so many times. I've heard it here at this conference a few times. Fill in your newspaper of choice. It's just an excuse for lazy security policy. It's pushing off the blame to somebody else of, I just don't want to get caught with my pants down. I don't want to do something dumb. And what this says to me is, I don't know what I'm doing, and I don't want to learn. And the I don't know what I'm doing doesn't bother me, but the I don't want to learn is what bothers me. Because it's going to be more and more important as we move forward security. It's not going to go away. It's not going to be solved by some magic box. And speaking of magic boxes, don't rely on these do-everything boxes, software, network devices, IDS machines. A lot of times they're multi-platform, and a lot of times multi-platform means we made it for Windows and somebody asked for it to run on the Mac, so we made it run on the Mac. There you go, off you go. The number of times I've seen apps that are cross-platform that write to their own app bundle and break their own signing continuously, the number of times they put it in users, shared, application, whatever, is just, it breaks my heart. They break all of the Apple design paradigms that are supposed to be in place for developers. They just kind of throw those out the window, and you can tell they spent a hot 3 days on the app. So the problem with that is a lot of those run as root on your system. So you have an app that was kind of thrown together, running as root on your system with who knows how many vulnerabilities. You probably look and you find the more you look. And lastly, you can't ever blame the users. Security is not their job. Security is your job. Management is your job. If you put in some kind of security block that they get around and something happens, that USB in the parking lot example, it's probably your fault because you didn't give them the tools they need to get their job done. And user training is, again, I'm going to keep saying this throughout the whole presentation, absolutely critical to the security of your business and really your job. Because if something happens, they're going to come blaming you most of the time. And that's really driven home by this because all hope is lost. Because why take the hard way of finding vulnerabilities, of exploiting things, of taking the long way around the tree when I can just ask a user, hey, what's your password? If you saw a local keychain item pop up, say, hey, I need your password for local keychain, would you enter your password? Probably. And the scary thing is, if I just got access to your machine, I can make a GUI prompt without admin access. So I can just pop something up. Hey, what's your admin password? I need it to install this thing. Oh, here you go. And then now I have admin access. That would be the escalation part of the little roller coaster loop-de-loop. So the good news is your company's money is best spent on you. It's best spent on training you, because you will always be better than automated devices, do everything devices, network security devices, because you can then train your users, you can create better systems, and you can then evaluate products that you do buy, because there are valuable products out there. And any environment can be secured. They're full stop. I've done, I don't even know how many environments now. Some of them more tricky than others, but we were able to secure them all. And to a very good extent without really bothering the users. It just takes some time, takes some effort, and takes really just trying. And a lot of, a lot of these tools, so the tools, the services, the apps, really fundamentally what they're doing is they're selling access to their experts at kind of a fundamental level. So if your company develops their own experts, that will just be cheaper than buying somebody else's experts. So what bad security looks like, and we're going to harp on this the whole time, I apologize, but the lockdown machines that are barely operational. If that worked, government response teams, incident response teams would be small. And I have to be careful how I say this, but they're not small. There's no record of services, apps, ports, anything. There's nothing. It's the set and forget. I imaged it, it's secure when I imaged it, and away we go. And because we don't watch, there's inconsistent configurations. People's emails don't work. Firewalls get turned off, that kind of thing. And users will always find less secure ways to do work. If you turn off Box, they'll use Dropbox. If you turn off file sharing, they'll use a USB drive. They'll always find a way. You can't block every single way that a user can change things on these machines. And what a properly secured device looks like is basically what we want to do, again, is make the attacker make more moves. That way we have more opportunity to detect what they're doing, to watch the logs, for them to make a mistake, really, is what we're trying to do. And when we do turn off parts of the system, it's more of a scalpel, less of an axe. So there are, of course, things we need to turn off, and of course, settings we need to secure. But you don't have to secure everything. And of the things you do need to secure, sometimes you only care about a very small part of that. When typically it's, we don't want our users to be admins, so poof, none of our users are admins. And computers are continuously inventoried with something like Casper, something like Chef, where you're just keeping a record of what the machine is configured. And that way, if you can know what the settings are, if you need to change something, you know exactly who you need to change it on, either automatically or manually. And scan for known vulnerabilities. What I mean by this is, for those familiar, you can mimic companies like Tenable or Nessus. I'm not sure if I'm saying that right. I think it's Nessus. But you can actually learn a lot from the marketing documents of security companies. We do X, Y, and Z. We protect you from A, B, and C. And it's like, oh, maybe I should be looking at how to do X, Y, and Z, or protect from A, B, and C. So if you mimic what they do and how they do it, you're really on a pretty good path. So, if you can, of course, buy Tenable or Nessus, but if you're limited in budget, look at what they do. Look at how they do it. They scan ports. Sometimes they have authenticated scans where they have a user who will check for your SSH version or your SSH ciphers or these kind of really in-the-weeds settings that could really compromise a device. And so how do we kind of get to this ideal? Because right now it's all been theory. It's all been kind of ethereal. So we designed to find the result of malicious activity rather than trying to find the malicious activity itself. We don't look for the virus of the day. We look for what it would do. It's probably going to make a user. It's probably going to put in a launch statement. It's probably going to change some settings. It's probably going to do something. So we have to look for what it would do and start detecting some of that. And what we also need to do is standardize as much as you can. Everybody uses their computer differently, but there are groups of computers or groups of users who use their computers in kind of a similar way. And what you need to do is collect as much meaningful signal about these devices as possible. By signal, I mean log data. I mean that inventory data where you have all the settings. And in the advanced talk, we're actually going to talk about how to parse out some of those logs and actually get into the weeds about how to collect some of those settings. So that'll be really cool. Stay tuned tomorrow. And so it's not just the IT systems that need to be modular. It's all your servers, it's all your employees, it's all your scripts, it's all your apps, it's everything you do needs to be modular because threats change daily. Attacks change daily. Compromise changes by the minute. You know, a computer that was fine 5 minutes ago is now fully compromised. So in a clear assignment of IT duties, so we pick somebody. Kelly is in charge of patch management. John is second if she's not around, basically. So you set up these kind of failovers. So if somebody says, oh no, we need to patch Office right now because there's some horrible vulnerability, we know it's going to be Kelly. And if we can't find Kelly, then we just switch over to John. It's that simple. And rather than the problem of somebody is getting murdered and everybody's standing around not calling 911 because everybody assumed everybody else called 911, it's a very clear you dial 911 kind of situation. And training systems for non-IT folks, it's training about the threats in plain English. So if you see a password prompt and you didn't do anything, that's weird, let me know. If you see a certificate issue on a site like Facebook, that's weird, let me know. Facebook is a bad example because you guys, HSTS, I believe, yeah? But anyway, if you see a certificate error pop up, let me know. You know, Facebook was fine yesterday and all of a sudden it's broken today. What's up? That's an issue. It's those kind of plain English alerts from them that you can get and you can really train your users quite easily to let you know. So we've been talking about Signal, we've been talking about logs. One of the most important parts of this is you get these logs off the device in some way. And it's for a couple of reasons. One, if the device is compromised, then somebody can just change the logs. And two, you want a single place you can log into and search everybody's logs. So that way, if you do searches, and effectively Splunk is you do searches and let me know if this search finds anything. That's kind of how the alerts work. Let me know if Dan logs into any system that isn't Dan, and then send me an email. It is effectively how those alerts kind of work. So basically, what we need to do is make sure that we can pipe all that out of the device while it's still encrypted. Because if we're sitting here at a conference and we're sending log data in the clear, everybody knows exactly how your device is working. If there's some kind of error that's going on, if there's some kind of outdated software, if there's some kind of problem, everybody would know about it who's looking. And that's why you need to make sure, absolutely sure, that everything you are sending is encrypted. And so there's a little bit of a risk if you are still sending your logs that an attacker has a machine and is in real time editing out these logs. That kind of risk is fairly low compared to somebody who has your device and had a static log file and had 5 minutes to change it. So he would just find all the entries that said his name and delete them. And so while we're piping these out, while we're forcing the attackers to make more moves, we have more chances of them showing up in the logs in some way that we would be alerted to. Is kind of the whole goal of this. And when you start looking at, kind of get into the weeds about some of these controls, should I turn on the firewall? Should I make users admins? Should I, do X, Y, or Z? Basically, you need to look at kind of the risk involved with that. How bad is it if it happens versus how likely is it to happen? So there's an example of a computer that's turned off in a bank vault. What's worst case is the computer leaves the bank vault, and we don't know where it went. That's kind of worst case. How likely is it to happen? Well, the bank has a lot of good security. It's kind of unlikely that would happen. What is more likely is somebody goes into the vault for a different reason, turns it on, attaches a USB thumb drive, pulls all the data off, and then walks out. That's the more likely to happen. So really what we need to concentrate our security on is not, is this computer going to walk away? Is what does somebody do to this computer while they're also in the vault? How do we stop them from doing anything to this while they're also physically in the vault? It's kind of you don't train for heat stroke on the South Pole. You got to kind of pick your battles and use your resources wisely. So now that we kind of a little bit know risk, I mean, what's a breach? What does a breach constitute? And so that's illegitimate access of any kind. So if anybody ever logs into your computer that shouldn't be able to log into your computer, that's a breach. If anybody potentially sees any data that they shouldn't have seen, also a breach. So if I leave a stack of personnel files at Starbucks for 3 minutes while I forget it, and I come back and, oh gosh, I got it, and there's nobody around it, nobody looked at it twice, still a breach because there was the possibility somebody came in, took a quick peek, closed it, and walked away. So we don't know for sure nobody saw it, so now we need to assume that somebody saw it. And that's kind of the breach. And then once a breach happens, you need to kick into some remediation events. So, in the Starbucks example, we need to get some identity protection for those people, and we need to alert them. And it's a fall down of events. It's hard to speak about exactly what those would be because they're so specific to your company and what kind of data it was and really the event itself. So now that we have the logs, we know risk, we know what a breach is, and kind of it's all coming together. We need to look at all this data, and we need to start deciding what is normal, what's known good, what does a normal computer in our organization look like. And because we have so much data, we can start grouping people, we can start looking at how the graphics department uses their computers, how accounting uses their computers. If somebody in accounting starts putting on Apple Remote Desktop, that's probably not right. If somebody in IT puts on Apple Remote Desktop, that's probably fine. I mean, it depends, but you can start making those kind of assumptions and analysis, and you can start really building a baseline and kind of a profile for what you should be looking for. And how you detect when something changes, you set up those alerts, those saved searches. I want to know if anything changes in the launched daemons folder. Let me know. Anything ever. You'll get a little bit of noise because some legitimate installers put stuff there, but it's better to know than not know. And how do you determine that change is bad? And that's, sadly, it kind of comes down to experience, and that rolls back to your best bet is to train you as the admin. So there's no simple answer to know what's bad. If Adobe pops up as installing a launch daemon, you as an admin know, okay, it's just Adobe, it's fine. It's the cloud updater, I think runs as a daemon. That's fine. But it's com.baddie.whatever, that's not fine. That's something bad. And sometimes they hide it as different things, so you'd have to know different naming structures in that. And it's a training issue. And I wish so bad that there was a simple answer to that, but there kind of isn't. And it is so specific to your organizations that there isn't going to be one if somebody comes out with one. It's really up to you to baseline and start looking and start watching. And so as we start watching, it's really about attention to detail. Because to this user, nothing's wrong. But sometimes it's a matter of perspective. Who was in the offensive security workshop? Anybody? A few people? Anybody notice the photographer that came in about halfway through? No? I see some nodding heads. So who was sneaking some work time in the offensive workshop? Pulled up some work email, pulled up something. That photographer could see all of your screens very easily. I was in the back of the room. I could see it. So if he wanted to, he could have just snapped a shot. He's got all of whatever data was up on your screens. Not going to be passwords, but it could be some personally identifiable information, some scandalous email that you're laughing at, or something inappropriate in the company Slack channel. And then they say, so-and-so at such and such company was looking at this in Slack. Oh my God, Twitter, huge incident. So sometimes it's just a matter of paying attention, turning down the brightness of your computer so they can't see it from orbit and that kind of thing. Who in that class plugged in the USB drive? Yeah. The fact that that's a question is... So, did anything change on your computer? Are you absolutely sure nothing changed on your computer? I'm not saying anything did anything maliciously, but they could have something on their computer that was watching for a USB drive, said, oh, cool, USB drive, I'll infect it. And then subsequent people would get that same virus. So it's not that people are mean-spirited, it's they didn't know it was there, and they unwittingly passed on the virus to you. And a lot of times the user will have no idea something's wrong. Oh, a keychain keeps prompting me like 30 times a day. It's kind of annoying, but whatever, I just click cancel. Or this weird remote desktop thing keeps popping up, but they said they're helping me. We have people helping us over in China, right? Oh, no? Oh, okay. That's probably not great. So that's why when we do all these things, when we do the log aggregation, when we start looking at all this inventory data, start noisy and then tune down. Let me know all launch daemon changes, and then I start tuning out, okay, Adobe's fine, okay, Microsoft's fine, okay, pick an app is fine for your organization. It'll be annoying. I don't try to deny that at all, but it's kind of the only way you can really catch everything. Because if you start from the bottom up, let me know anything that isn't Adobe, anything that isn't Microsoft. You'll have so many exceptions that you'll miss true security events. Whereas if you tune down, you'll get things that kind of make you go, oh, I didn't know about that. It's like the Jurassic Park problem. They were looking for 53 dinosaurs, so they found 53 dinosaurs, but there were 65. And then death, destruction, all this kind of good stuff. It's that kind of methodology. You need to be able to find what you didn't know existed without driving yourself crazy by getting an email, 3 times a second. And I'll say something that's a little bit, I didn't think it was, but incendiary, is 99% of my users are admins on my machines. Almost everybody is. And the reason I do that is because I put it together a little bit earlier. So I looked at, what do I really care about? I care about you getting into the terminal, running sudo, and just changing some really low-level stuff. That's what I care about. I don't care if you install the Verizon helper app so you can connect to your home internet. It's wrong, but fine, you can do it. I don't care if you change the desktop background. I don't care for a lot of things that you need admin rights to do. But basically, I care that you don't change the file vault users. I care that you don't change some low-level firewall things. I care about some really low-level networking things. So all of that I care about is completely invisible to the user. They'd never know. So what I did is I only allow management users to sudo, management being IT. And then users are still able to install software, be admins, change their desktop picture, whatever they want to do. And basically, because we are collecting all of this signal, all of this log data, all of this change data, all of this inventory, we know when somebody's up to something. If somebody runs that dilib attack and tries to write into the sudo admins folder. And we know if somebody tries to sudo when they shouldn't. And sometimes, for all of our best intentions, somebody legitimately needs to do sudo because packages are written wrong. They have scripts that sudo when they didn't need to because they're already running root or stuff. The Verizon installer is a perennial punching bag, but they do have some scripts in there that require sudo even though they run from an admin prompt. So I don't understand it, but they did it. So what I did is in the same vein of that plain English. Not, hey, do you want to restore sudo rights? Or, hey, do you want to be a superadmin for a little bit? It's, did installer not work? Just in self-service? Click this in the background. It gives them back sudo rights for 30 minutes. So then they can install whatever it was. If they try to get into some funny business where they start to change some low-level system stuff, with all that log data, with all that inventory, I would catch that. And a lot of stuff I can change back automatically later. They don't really care why something didn't work. They care that it didn't work in most cases. So this one, I'm actually a little bit scared of this slide. This one's going to be, a fire starter. But so passwords and complexity. We'll talk through this. So stay with me. I see some of you reading ahead and going, oh. I have rustled the graybeards. So there's an XKCD comic that came up, I don't even know how long ago, quite some time, that said, we've designed these passwords that nobody can remember and are still not that great. So if you just did a sentence with 4 random words, correct horse, battery, staple, and made that your password, that's much better than most passwords people would choose. And you have some selective listening with some people of saying, if you push all of them together and make one big word out of correct horse, battery, staple, that's terrible. The reason they say that is entropy, which entropy is basically the measure of randomness of a given word, string, password. So how random is that password? How hard is it to guess? And it's a little bit simplified, but for this class, that's what we're going to go with. And my argument is that perfect passwords would be true random, massive, 60-character things that just nobody could possibly remember. And that's the perfect world, but in a perfect world, there also should never be traffic on the highway because everything should just merge together, gear it off, everybody move forward. The problem is cars are driven by users and computers are driven by users, and they will pick the path of least resistance. So basically, we accept a little bit of risk in, okay, if somebody got this password off device and they had an NSA level cracking rig, they could possibly get it in 3 years. Okay, fine. But what I argue is scope. So actually, I agree with this XKCD correct horse battery staple, given that you make it a true sentence with some kind of punctuation in there. So don't put the punctuation at the end, correct horse battery staple, and like yell it or ask it a question. Put in the spaces and add a punctuation in there randomly. So make it a question and answer. Correct horse battery, and then staple is the answer, or something like that. So if you add in those spaces, those special characters, actually it adds a lot of that randomness, that entropy to the password, enough so that it's an easily rememberable password that is still very secure. And the scope of that would be just for the actual computer itself. Don't use that for stuff that's online. Just use that for Apple products that have all of this security built in. And then if you need to do something online, use something like LastPass, something like 1Password. Get that horrible 60-character true random password, and then protect your LastPass or your 1Password with something like correct horse battery staple, a different one from your login, please. But that is completely agreeable to users because they usually think it's funny. And you can just make it as silly as you want it to be or as long as you want it to be because it's just a few words. It can be 8 words. We don't care. That's still pretty easy to remember. And users will usually be okay with that. So it's a nice compromise. It is a perfect world where even if you got it off device and you gave it to the NSA, could they crack it? No, it's not that. But it's a really good password that isn't Dragon 1994 puppies, because that is absolutely crackable by real world people, and it would not take very long at all. It's a matter of, I forget the math, but maybe a few weeks to get it, if not less, if it's real dictionary words. And so with all of these different kind of controls, we have to enforce them in different ways. So there's some controls we want on all the time, like these passwords. We want to have passwords enforced all the time, so when it comes time to change, you don't just turn off the setting and then change your password and then turn on the setting again, because then I can just make my password whatever I want it to be. It could be 1, 2, 3, 4, enforce the password policy again, and if I changed it while it was on, it would have to be this big, long complex, but I broke the system. So the rotation frequency, I missed that point. So the rotation frequency, I almost never rotate my passwords for my users. I only rotate them once a year, or if we suspect a compromise of the box. Because the scope is so limited and because the password is so strong, it makes it much better than these 90-day rotations. Because if you do a 90-day rotation, they're going to be iterative. They're just going to do add a 2, add a 3, change one word. You're not really buying any security, and you're just hassling users a whole bunch every 3 weeks. And what's the number one complaint amongst users? I bet you is change passwords. Yeah? We can just nod. Yeah, we're getting nods. So with how we control those things, with sometimes we want control all the time, and sometimes we want to control some of the time. There's a little bit of leeway. If you want to turn this on for a half hour, not the end of the world. So the way we do that is a mix of configuration profiles, which I'm sure some of you just learned about in the previous session, and scripts. Scripts can be your language of choice, Bash, Python, Perl, whatever you want to do. But basically what that buys you is for anything that you really, really care about to be always on forever, profiles. It can be a setting, it can be an Apple built-in, whatever you want it to be, as long as you want it to be always on forever, profile. So if there's things like a file share, where I'm going to have it off by default, but if you're sitting there with your buddy and you need to send him a file, so you turn on your file share or AirDrop or whatever, that is so much better than having it on a thumb drive that is most likely not encrypted, that having a file share open for a half hour, not the end of the world. So basically, because we collect all this data, because we collect all the signal, because we have an MDM, we can allow them to turn it on, and the next evaluation cycle will say, oh, file share is on. How long has it been on? Less than 30 minutes? Go ahead. And if it's over 30 minutes, then we then turn it back off. So it's this kind of dynamic security that allows your users to really get their job done easily. So it's, again, is making the right thing easy and making the hard thing frustrating. And some of the things that you want to have on with profiles are like Firewall. You want Firewall to always be on. You want the password policy to always be on. You want the Firewall to always be on, and in certain configuration. And it's that kind of hand-in-hand deployment that'll really make a great experience for your users. And I think you will, I hope you do, get thank you notes from your users of thank you for not locking this down, turning everything off. I actually like using my Mac. You know, I have something where I can trust that I can do my banking on this and I know this computer doesn't have a virus. I know I can keep whatever secrets I need to on here, and I know it doesn't have a virus, it's not compromised, somebody isn't reading my stuff. It's that kind of confidence that is really, really, really great. And again, with that confidence, we're going to talk more about that in the advanced talk, more of how to actually do that. We'll work through some examples, some scripts, and some configuration profiles. It'll be really cool. Tomorrow, same time. So antivirus. So this falls into the same problem as a lot of the multi-platform tools, where written for Windows kind of works on Mac. So there are a lot of times, most of the time they're signature-based. So they only know threats that have been seen before, have been profiled before, the wire lurkers of the world, and those kind of things. They don't detect somebody getting into your computer and running a custom script that they wrote. That's not to say somebody is sitting on the other end of the computer and typing and trying to attack your computer. It means they wrote their own automated attack. So that wouldn't be picked up by the antivirus. And these antivirus are almost always running as a root process. So you have yet another root process that may or may not have been coded correctly running on your system that may or may not be signed. And I can see if you're running an AV product without being an admin. So if I get on your box at all, I say, oh, they're running an AV software, so I just won't do anything that AV software would know about. Great, I'll just make a user. I'll just write a new script. I'll just recompile something that already exists with a comment at the end. Something as simple as that. So I run it on my systems. I don't run it in the continuous evaluation mode. I run it with an eval at night just to be a good corporate citizen so we don't pass something off to a Windows machine. So when I pick an AV, I make sure it has all the Windows virus signatures in there. So I don't want to be the person that sends out the email to all the Windows machines and gets them all compromised. That would not be a great day for me. So it's just kind of a sanity check, more so than any real first-line protection. And with a lot of these things, we can think about what would Apple do. And I don't think about that in the, the Steve Jobs way. I think about it in the, how did Apple solve problems similar to mine? So when Apple came out with the app Firewall, the one we know and love from the GUI, we can click through and say Firewall, and I want to let little snitch do whatever it wants on the network. What that actually does is control the very low-level PF firewall that is a hardcore, I think it's BSD, software that like runs literal routers and protects enterprises. But what it does is it puts a happy face on that hardcore tool of saying, okay, so little snitch ran, it is asking for ports 1, 2, and 3. Whenever it asks for them, give it to them. So it reconfigures PF to allow that to happen. And as soon as little snitch isn't running anymore, it then turns that off in the configuration in PF. So those ports aren't always open, and it's a nice, easy way for the user to have a very good firewall. And that's why I love application firewall so much, is because it has the underpinnings of such a great firewall. And if we look at that, it's a lot like the sudo example, where everything the user cares about, I want little snitch to be able to talk to the internet and the internet to talk to little snitch, however we want it to do. And all I do is click plus little snitch. With the admin thing, I can do most of the things I want to do. I'm stopped from a few different things I shouldn't do. And if I run into a problem, I have a button to click that says, hey, I ran into a package that wouldn't install. Fix it for me. Little do they know that's sudo, but and then they are able to do their job. So it's using the tools Apple already gave us to get this job done. We don't have to reinvent the wheel. We can just put happy faces on some of these low-level tools, and it will do the thing better than we could have ever programmed, because Apple has literal teams of people working on these things, of like the best security folks in the world working on these things. And that's my little soapbox. I'll get off. So some of the tools, this Patrick Wardle guy is really, really great. He's been putting out a lot of free and open source tools. All of them are free, some of them are open source. Not all of them are open source. Well, one of this is kind of an example of a good way of looking, this ransomware. So what it looks, files change in a certain way, typically when they're encrypted, some of the metadata just on the disk. So what this tool looks for are those changes to the files on the disk. It's not looking for the encryption process running. It's not looking for anything like that. It's like, what happens to a file when it gets encrypted on a disk? How does it change? Does it get bigger? Does it get smaller? Does it change in different ways? And that's what it looks for. So sometimes it has false positives. If you watch a video on Chrome or something like that, sometimes it pops up, says, oh God, what's happening? It's some of the DRM in Chrome does that sometimes. But basically, it's these generic checks. We're not looking for something we already know about. We're looking for types of behavior. Oh, something's encrypting all of my files. Did I mean to do that? Is it signed by Apple? I mean, it's how bad is this event that's going on right now? And that all happens all in this app. So you can just pipe just the alerts up to your log management, and then you can write an alert that says, hey, if this search for anything from ransomware pings, send me an email right away. That's super not good. And even with the ransomware, it will pop up a notification of the user and says, did you mean to do this? Yes and no. And if you hit no, it will kill off that process. It doesn't keep it dead. If it starts up again, it'll then pop up again. So you'll get a loop. But at least it'll slow it down enough. And a shout out to the Facebook guys. I absolutely love OS Query. So in the same vein of people have done your job for you in some ways, these guys have done you a huge favor with writing OS Query. So SQL commands look terrible when you first look at them. They actually are not that bad. And you can query some very complex things from the system with this very easily. One of the perennial examples is show me all launch daemons that run at load and keep alive. So anything that runs as admin will start when I boot and will keep itself alive at all times. Super bad, super suspect. You can very easily make that in OS Query, and it's almost plain English. And if SQL is new to you, there are about 1 billion different ways to learn SQL on the internet. And it is just absolutely great. So thanks, Facebook. Thanks, guys. That's awesome. And they're always continually adding stuff to it, and it's open source, and people keep adding new modules. You get new ways to query new information from the systems. It's really, I can't say enough nice things about it, so I will stop. So with the user training, this is really cool. So this is the simple phishing toolkit, and as you can see, it has a responsive dashboard, just like we always wanted. Basically, you can make these phishing emails out to your users, and you get alerted who clicks, who doesn't, and that kind of thing. So you can start phishing your own users to publicly shame them, to let them know in private, or whatever you deem appropriate to really drive home the message of, I could have just compromised your device. This could not be more bad that you just did this. And it's not it is one of the primary tools I use to test my users, because that's typically how, whenever something does happen, happens, without giving too much away. So somebody clicks on a faulty link and enters in their password or their credentials, and then those password credentials get passed to somebody else, and then they just have legitimate access to these machines that wouldn't typically trigger any kind of alerts. And that's why we don't tune out the noise at first. We say, that's weird, I got a login from China. What? Nobody's in China. And that kind of log reporting, where if you tuned out all logins from Dan, you wouldn't see that. And that's kind of why you need to start noisy and tune back down. We kind of have all these themes that keep looping back, so forgive me for repeating myself. And really from there, if they suspect a real phishing attack is you trying to trick them and publicly shame them, I think that's success. Because if you've made them that suspicious, if you've made them that paranoid about clicking links in email, job's almost done. I know I said security's never done, but that part, you're sitting pretty for there. If they think a real phishing attack is you trying to trick them, you're doing your job right. So for all this, I couldn't possibly hope to touch on all of this in a single talk, so I made a slide of all these training courses. They're not typically cheap, but they are really, really, really great, especially the SANS. The Certified Ethical Hacker I don't have myself, but I've heard good things from other people. It's more of a generic, a little bit less techy kind of talk. What I didn't talk about today were like some of the built-in Apple protections, SIP, XProtect, Gatekeeper, some of the privacy things they're putting in. The reason I did that, I left that for Apple themselves tomorrow at 9 a.m. There's so much to cover that I focused on just what wouldn't come from Apple tomorrow. And kind of the key takeaways from this that I would like you to have, if the user will never see it and would never notice it and it's a security control, absolutely turn it on and make sure it's always on. If the user wants it, if it's something like a file share, if it's something like to turn on, to change the desktop background or something like that, let them do it. And if it's something like a security control, let them do it for a limited amount of time. And we fall back to that risk assessment, to how bad is it if this happens versus how likely is it to happen, to kind of help you, all right, you can do this for 5 minutes, or you can do this for a day, or you can do this for an hour. And you kind of gauge that time by how risky it is to have whatever that is on. So for file shares, typically I do about an hour, because sometimes they're bigger files, and it's on a worse network. And if it's something users shouldn't have, absolutely control it, absolutely check it all the time, and make all of your alerts center around that. So something like sudo rights. I have all the alerts in the world about sudo rights and the sudo configuration files and the root user and those kind of root processes. That's what I really, really care about. And the good news is security is complex, but it's made up of many, many simple pieces. So it's fairly easy to get started. It's fairly easy to get on a roll. All it takes is deliberate practice. All it takes is being better than you were yesterday. And if you do that, you'll be amazed where you are in a few months. And that will be the end of it. I left enough room for a lot of questions because I figured there would be. Thank you. Are there any questions? I'm not going to throw it that far. We're going to hit somebody's drink. Sure.
So you talked about creating baselines. I'm from a Fortune 100 financial services company. We got about 6,500 Macs. 80% of those are developers, digital designers, software engineers. So you said you helped out Google and Facebook, which would have a lot of developers there too. How in the world do you create a baseline for a large population of developers who are constantly installing things that they need? It's legitimate.
Yeah, so I didn't...
launch statements, launch agents.
I did not actually help Google and Facebook. I used them examples of people doing it right. No, I didn't help them at all. They got it covered.
Okay. in a company like Google or Facebook or our company, where we have thousands and thousands of developers, creating a baseline, where would you even start?
So it's hard, and when you start noisy at that level, you start really noisy. And you really have to look at more the persistent angle and more of the users that aren't your normal user, and also it's hard to start without knowing your specific environment. Yeah, so where I would start is just start watching. Start noisy and turn off the alerts and start watching. Okay, so we typically install no apps that I didn't write, a whole bunch of apps that I did write, and nothing persists through reboot. Okay, so I start looking for apps that you didn't write that get installed. I need to know about those. Okay, I need to know about apps that persist through reboot and start to keep alive. Okay, I need to know about those. And then we start dealing with admin rights, and we start spidering out to what are they actually doing, what files are changing. It spiders out extremely quickly, but I would start noisy and turn off alerts and start just learning. Start using Splunk, some of their data collection, some of their graphs, some of their stuff like that. It's not the best answer in the world, but it's hard to really give a generic answer to really where to start, because it's hard to know what your users are doing without it. And I guess that's the best I can do, is just start noisy and start watching. Anybody else? Oop, behind you. Oop, wait for the...
You mentioned Little Snitch. Are you advocating putting that on all of the users' computers?
No, I was nervous and was looking for an example, and for some reason that came to the top of my mind as a network utility. I'm not sure why. It's a bad example, so ignore the Little Snitch part of this. We'll just wave that away. Anybody else? All right, watch out. The drink's coming in up front. Hold your... There we go.
I know you mentioned turning on Apple's software firewall, and I've seen some environments where they said, okay, do everything in CIS and Macs that are bound to the domain. I said, well, this doesn't make any sense. There's just fights for security. It's like, tone it down a little bit, because you have these very expensive systems for people who are designers and stuff. So I guess I have two questions. Is one, how do you start getting some people in, I guess, some security to fight against, I don't want to say fight against their old habits or old ways of saying, hey, let's just lock everything down. Like, what's your approach to try to get them to soothe them up a little bit? And then the second thing is, I think in the past I've seen issues where Apple's software firewall has caused issues with Adobe Creative Cloud checking in for software activation and stuff. And so how do we when there's stuff like that where it can get into the way of applications that we need users to run, possibly, how do you justify if you're in an environment and it's protected on the LAN, these devices aren't, if we have desktops that aren't leaving, let's say, the private LAN, would you still turn on Apple's software firewall, or would you assume, okay, well, there's a firewall to get onto the network, we assume protection from that, there's little risk of that, would there still be a reason to run Apple's firewall in that kind of scenario?
Absolutely, I would. So I hate the crunchy shell analogy where we have the border firewalls and everything in our network is trusted, protected, so we don't need any controls. I don't agree with that at all. Because then if somebody gets through that one point, they have everything. They have unfettered access to anything they want because nobody's running a firewall on the inside. For the Adobe stuff, I kind of put that a little bit on Adobe. Because I think I remember, it was about 2 years ago or so. Was that the one you're talking about with Adobe? Possibly. It was a coding error that they did. There's always going to be hiccups when you start turning on these things. And the guides, the CIS, the STIGs, and those kind of things were really written, here's the perfect world, cut out what you can't do. If we had a perfect world, if we could secure everything about this device, turn on all of these things. And then, so when in the real world, when we was like, okay, so our users are graphic designers, they can't have this. So then you just disable that one thing, but have everything else. Rather than having a fall down of, for graphic designers, do these 12, for developers, do these 30, it just makes more sense to have one big list, and then you can just cut out according to your environment of, we can't do this, or we can't do that, or we don't want to do this or that.
Okay, thank you.
Sure. Anybody else? Oh,
You mentioned the NVD list of vulnerabilities, and then on the other hand, you have all the admins in your environment. The security team I work with, their current perspective on that is by letting them install software, we'll end up with more of those potential vulnerabilities on the machine than if we control it. So you talked about kind of using the scalpel and locking things down. Why isn't software installs something that you want to negate in order to prevent the number of vulnerabilities?
so it's kind of a nuanced answer. So I want my users to have ownership of their machines. I want them to like using their Macs. And if I take away admin rights, this isn't their Mac, it's a Mac that IT gave them. So they will inherently treat it a little bit rougher. They won't care about it as much. They won't keep the screen clean. So if you walk around and you see their users with like fingerprints and just absolutely terrible screens, they don't care about the machine at all. It's just an appliance. It's a toaster to them. I want them to care about their machine. I want them to have all the apps they want. If they wanted to use Slack to talk to their friends, but the company doesn't use Slack, whatever, go nuts. That's fine. Because we're tracking everything, because we're keeping track of the application installs, and because we have an MDM on these devices in some way, shape, or form, if an app that's installed is installed as a problem, we can immediately uninstall it, and we'll immediately know about it. So it's not the perfect world, and I don't think there is any security perfect world, but I think the risk is way worth the reward for having them be admins. Way back there in the back?
So do you close the loop then with management? I mean, say the user installs coupon printer because they want to print all their grocery store stuff.
What do you do when the user does something dumb that really causes problems? Yeah, you can go back and uninstall it, but is there any way to, I don't want to say just educate the user, but and penalize the user sounds bad, but where's that middle of, hey, you did something bad, we trusted you with the machine, and now I got to clean it up?
Yeah. So the question, we missed a little bit on the speaker. The question was, do I close the loop with management, MDM of some kind? And the answer is yes, I do. Sometimes I do. It depends on what it is, but sometimes it's as easy as a notification center that flashes past, hey, we uninstalled X that you just installed that's known bad software. Sometimes it's an email. Sometimes an email to them and their manager. I know all of the people in security hate this, but it's a user-based control where it's mostly, I don't want to say shame because I don't shame people. It's letting them know what they did was bad in the least intrusive way. So if it's like not a big deal, we'll just do a notification center or a Jamf pop-up window for those of you who use Casper. Or sometimes it's an email, and all of that's generated sometimes by the log, and sometimes it's a manual process of, that was really weird and super bad. We got to really have a talk. So it depends on the severity, but usually it's just an email or some kind of notification to really close the loop and let them know, don't do that again, rather than them trying to install and install and install, because I'm saying, that's weird, my package didn't work. Then they'll click the my package didn't work button in self-service and install, and it would not be good.
Can you blacklist apps?
I can. I use it very limited scope. I don't really blacklist app. I rely on Gatekeeper and XProtect to do that for me mostly.
I think it was brought up before, but I think a lot of us struggle with, we want, as admins, users to have a great experience. Our security teams are the exact opposite. How do you approach that discussion? Because I mean, our password policy just went from 180 days to 90 days because it's more secure. And we got emails, we got tickets, here's why it's not, but nobody cares in the security team. So like the discussion, how do you convince security teams that have the kind of old mindset to consider some of this stuff?
It's the, I think it was Socrates who did it, but like you ask, okay, so what are your concerns about password policy? Why did you change it? What changed that made you say, okay, 180 is no longer good enough, let's go with 90? What changed? What are you worried about? We're worried about X, Y, and Z. Okay, why are you worried about X, Y, and Z now? And then why, and why, and why, all the way down. Because you have to make them realize it. You can't tell them what to do because they will never listen to you. And that's not a dig on you at all. It's just they're set in their ways. You have to ask enough questions for them to realize, oh, and then that's really the only way I've seen change. They should spend money on a second consultant that comes in and says, nah, you don't do that.
So I'd like to work on a training program for my users. Where can I get started, or are there some good resources that you can provide to get started on building that program?
I don't know off the top of my head any right off, but I know there are a lot online as far as security training for users. There's a lot of really, really ugly PowerPoints. But do you have one off the top of your head?
Can I toss this over here?
Yeah, why don't we toss it over?
Props to Nate Felton from RIT for this one. And the notes that we took for this, he mentioned overthewire.org/wargames, which is learn and practice security concepts in the form of fun-filled games.
There you go. Hopefully, I think that's might be more for admins, but hopefully it's for users as well. For user-related stuff, there's a lot of documents online, and you might have to create your own PowerPoints and that kind of thing, but there has to be somebody who solved this somewhere online. Mike? We'll get him.
Go ahead.
Oh, I'm sorry. Go ahead.
So we just deployed a tool called Apple Enterprise Connect internally, and it's a good tool, but it prompts users for their password, AD password. And so with all the training that we've done to basically deter them from putting their password into pop-up messages that appear, it was very hard to get them to trust this tool. So we sent an email ahead of time. We popped a notification that said, we're going to ask you for your password. Then the tool finally asked for the password, but we still had people contacting us saying, we're being phished. What is this? And they, rightfully should be afraid of these things because that's how a lot of, these attacks occur, is that people get tricked into thinking the tech support is asking for credentials. So how do you, oh God, I don't even know how, how to phrase the question. So we've trained them too well in some cases, I think. So how do you make your communications to your users official enough, sign them, or some sort of mechanism by which they can verify that it's an actual communication from your IT department, right?
So first, I love Enterprise Connect. Enterprise Connect is the best thing. And second, congratulations on your users, because you've done an amazing job, apparently. But so basically what I do is I do the same thing that Apple Security does. I send out a PGP signed email. For the users who don't know what that means, they go, oh, wow, that's super secure. Okay, that's great. And they can check that signature against ones that I've previously sent, and they can verify that it really is me. As far as user pop-ups, basically what I do is put in the company logo. So the company I'm doing work for, of whoever, I put in their company logo in the pop-up. It's not the best, but sometimes it's enough to get the user's confidence to enter in the password, rather than the system keychain prompt or just the little lock icon. So they know that this is different, this is probably okay, and especially if we send that email ahead of time. And sometimes your users are trained entirely too well, and none of that works. Sorry? At least they called. Yeah, at least they called. That's the good thing.
Better than the alternative, but we get people doing the opposite as well. It's like, oh, tech support from China.
Yeah, great. Oh.
So to answer the first question and address his, we do something every year called Hacktober.
Mm-hmm.
We did a pretty good write-up somewhere. You can probably search Facebook and Hacktober. It was pretty good. Basically, we drop USB sticks on the ground, see who's going to pick it up. We find unlocked machines and mess with them. We phish them, a whole bunch of stuff. But basically, anyone that falls victim to one of these things gets posted to a group about what happened, cool, and how to prevent it next time. But also, if you catch the people in the act of trying to phish you or doing anything like that, we reward them with swag, T-shirts, posters, that kind of stuff. So now they are rushing to tell us about this new thing that they found to get free stuff. And so when I do do a prompt, and even if it's branded, yes, they still want to know, is this legit? So they have a standard place and to go post this, but somebody already had beat them to it, so they just know that, oh, okay, this is legit and all of that. So
Cool. Thank you. That's actually a really good idea. Any others? I know it's almost lunchtime. We have about 5 minutes left. Oh, we have a whole bunch. Okay. It's coming to you. Hang on, ready? I undershot it, sorry.
So let's say you have contacted a user who has done something bad, and you have contacted them and talked with them and sent them a link to some training, and they continuously, over and over again, continue to do the same thing. At what point do you just say, you know what, your machine's getting locked down?
All right, and it happens, it depends on the company, but after the third or fourth time, there has to be some kind of teeth to these consequences. You can't just slap on the wrist and say, don't do that again. There has to be something. There has to be management involvement. There has to be HR actions, something. Because they're not only themselves at risk, but also the company at risk is how I usually get higher-ups on board with this. And it depends, but usually after the third or the fourth time, then the consequences really start happening where you get a super locked down machine, or you have a very serious discussion with HR or your boss or something like that. It's kind of the simplest answer, sometimes the best, Anybody else? Right behind you? Oh, can we hit him the box?
Just real quick, I was just trying to get an idea of what some of these like change detection systems, maybe open source versions first, and then the Cadillac versions, just a couple names, so I can do some more research.
Sure. The easy way to do it is with Casper Recon. The easier way to do that, even still, is with OS Query, because basically what you can do is you can have it baseline for you. This is all the settings as OS Query knows them. Every setting, everything on in OS Query, so check everything. And then you can say, let me know if any of that changes. And then it'll write to log files, is effectively how it does it. That's a free and open source tool. There's a few paid ones, Tripwire's one. I'm blanking on, I know there are a few others, but if you Google Tripwire, you'll get some of their competitors as well.
Perfect, thank you.
Anybody else? Cool, I think that's lunch. Thanks, guys. Thanks for all coming.